Alright, so this is a fabrication video for the nylon coil sensors. So the raw material we use to make these sensors is this material. It's a 1717 DTEX 2PLY plus B material. DTEX means the amount of nylon and silver in this material. So I'm gonna start with showing you the setup. So to make the sensors, the way we make it is first we attach this thread to this stepper motor and this weight holder on one side, and this wire is to keep the thread from rotating. So once the motor will put winding on the thread, it will become coiled, and once the thread is coiled, if I cut the thread, it will uncoil itself. So to keep it from uncoiling, we do a process called annealing process, where we short the thread by using a short circuit and a transistor, and also a microcontroller. And then I will show the whole process step by step and what to do. All right. So to begin with, you take a piece of thread, and so right now the way we have the process set up and the formula, they only work under the length of 50 centimeter. So if you go above 50 centimeter, the sensor will break or it'll be inconsistent. And also one thing forgot to mention was this material is very delicate. If you touch it too much, or if you keep playing with it, it will start to show inconsistency, and it will break in the annealing process. All right. So I'm just gonna start by cutting a piece of thread. So you can kind of like eyeball it and then cut it. And then you take one side of the thread and you make a knot around this stepper motor with a hanging wire to it. I will explain the reason why we have this hanging wire. So the knot is just a regular knot. You make a circle and then you go across it and you tie it like that, and you do not want to use a lot of force when you're doing that. You kind of go slow and try to make the wire snug with the try to make the thread snug with the metal wire, and then you do the same process for the second one more time. Make a second knot on top of a knot. It's kind of tedious, and you can use tweezers for it, but I kind of like doing it with my hands. Alright. Alrighty. Now I'm going to repeat the same process for the bottom part. And this is a weight holder, and this whole thing weighs about 30 grams right now. I'm sorry, 50 grams right now. And first you can kind of eyeball the length you need. So I'm kind of aiming for about 45 centimeters, and I'm gonna put the thread, this thing, next to 45 centimeter and pass the thread through the wire. And it kind of tells me how much thread I need left out when I'm making a knot. So then you can put this thing anywhere you like or you feel comfortable with.
I'm just thinking those capacitors right there.
Alright, let's make a knot. And you kind of do the same thing like we did above for knotting. You don't want to put too much of a force, or you don't want to pull too much on the sensor, which will damage the raw material if you do that. Once the knotting is done, now you want to let it go here, but you want to release it very gently, because if you drop it, it will kind of yank the sensor, and which will do the same thing as damaging the material. So you can see, let it go gently. Now you can cut the excessive material. I'm going to start with the top and then the bottom. Alright. Now the next step is to measure the length of the sensor. So the length has to be measured from this point to this point. So the tip of the top wire to the tip of the bottom wire. And I already measured that from here to here is 30 centimeters, so I'm going to add the rest. This is about 18, so about 48. So I'm going to let me double check. Yep, it's about 48. So you can come to this Excel sheet here and then put in 48. And the reason we're measuring this length is because if you put too many windings on a thread, the windings will start to wind over the winding, which is called overcoiling, and you don't want to do that. And the next step is to measure the resistance.
Simulated basically to simulate essentially a normal system using
Alright. So when you're measuring the resistance, you always want to attach the top wire first, and then for the bottom wire, you kind of want to gently attach it and then gently let it go. And it's about 76.3. So I'm just gonna put that here. I'm sorry, 73.6. All right. Now the next step is to, once I know the number of windings I need. So the number of windings was determined by doing multiple experiments and seeing when it starts to overcoil, and then we kind of came up with the ideal value, which were about 11 coils per centimeter. So right now I need about 533 winds for this thread. So the way we do it is using a stepper motor, and this is the power supply we use for the stepper motor, and also for the annealing process, which I will explain later. So it has two different power supplies built into one power supply. So the stepper motor can operate between 12 to 20 volts and at 3 ampere. So I'm kind of like in between at 60 volts. So I'm going to turn it on. And the other thing we do is, so to control the stepper motor, to have the number of windings we need, we kind of made this cord which will take the number of rotations you need and then control the stepper motor, and it will stop it when we achieve our goal. And you can see this cord, and we'll tell you how to attach it with the Arduino Mega microcontroller and what kind of wires you need. So I'm going to start with uploading the cord. And then it was 533. And then enter. And the stepper motor will start. And you can kind of see the number of rotations we have put in this serial window. So it's at about 91, 94 right now. Yeah, it's gonna go up to 533, and the length of the sensor will start to decrease as it will start putting windings on it, and also resistance will start to change again. And this will be necessary for the annealing process. So the annealing, like I explained earlier, is using a short circuit. So we use this transistor here, which is basically allowing a current from this power supply to flow or stop. And then also the same microcontroller we are using for the stepper motor is also controlling this transistor, but a different code is used for that, which I'll show you later. Process. All the wiring diagram and everything is explained in the code or in the midterm report if you're interested.
Cool.
All right, the wiring process has been finished now, and you can kind of see here in this window, it will show 532 because it started at 0. Now, the next step is to find the right amount of current for the annealing process. The annealing process is kind of different because we limit the current, not the voltage. The resistance of the sensor changes when it's annealing. Therefore, but the current always remains same, and the voltage will change as the resistance of the sensor will change. Not on clock thread will change. All right. So I'm gonna first measure the length of the sensor because the current is the function of length and the resistance of the sensor. So we are at about 39 for the length. And you can put that into the Excel sheet, which is available in a Google Drive. And then the same way, like I explained, when you're getting the resistance of the thread, you want to attach the top alligator clip first, and then the bottom. And when you're attaching the bottom one, be careful not to pull down on the sensor. So you want to go gently and just attach it and then let it go. And it's at about 74.7. So kind of remains the same for this one.
Yeah, I don't know, like I want to talk what? Like I don't know what is anything like I wasn't planning on talking. It does too.
So the current value I came up with using the formula I put in the Excel sheet, which is also given in the midterm report, if you're interested, is about 0.27. So I'm going to put in the current value. So for that, to limit the current, I'll just kind of show it here. So you can see here in this power supply is the first one and second one. You can move between which one you want to adjust or program between using these tabs. So it's set, the current right now here is set to 0.27. So every time if the voltage exceeds this current, the voltage will drop. So, but if you want to change it, all you gotta do is use these buttons to come to this current section here, and then you can say 0.27, then press OK. Alright, after this is done, now you want to connect these two wires which are coming from the transistor, which are letting the current flow from the power supply to the thread. And you will have to do the same thing like we did with the multimeter. Attach the top part first, and then the bottom part. Very gently. And then once this is done, you can turn on the power supply and then upload the second code, which is also given on the Google Drive. So the way the current is supplied on the sensor is by sending pulses, which for half a second, of supplying the current and half a second not supplying the current, and then it will repeat it for 100 times. So I'm gonna start it. And you can see when the current is supplying, the sensor will actually start to move. Every time the current is supplied, the sensor will start to compress, and when it's when it's released, it will start to kind of unstretch itself. And we'll do this, keep doing it for 100 pulses. And sometimes it will break, and that will be probably due to some impurities in the material, or maybe the material got bad over time, maybe somebody's been touching it, or or maybe the knotting process isn't very snug. So sometimes the knot is away from the wire, and which kind of decreases the resistance of the small thread, and it will break due to that. But right now it's not showing any of that.
Cool.
Alright, once the annealing process is finished, you can kind of see here about 99 pulses have been done, and since it started from 0, it's actually 100. So now it's the time to cut the sensor. So to cut it, first you gotta take off these alligator clips. So to take it off, you first take it off from the bottom one, and then take off the top one, and then when you're putting it on, it's the other way around. But now, removing the sensor is kind of tricky. You do not want to cut it when it's stretched, because it's like a spring and it will kind of tangle itself if you cut it right now. So to cut it, you kind of move it gently a little bit, but not too much. If you move it too much, it will tangle too. So you kind of lift it up a little bit. Right? You can kind of see this bend in the wire, which is not a lot, but it still tells me that sensor is no more in the tension. And then I'm going to cut it very slowly, and you don't want to, and then that's it. And you will see a little bit of unwinding, but not too much. If it's too much of unwinding, then sensor is considered inconsistent, so the annealing wasn't done properly, and which could be due to multiple reasons. Because we had a limited current, it might not have ever hit that maximum current point, and then the sensor didn't anneal because of that. So sometimes you will have to increase your initial voltage, and sometimes you are limited to the initial voltage of 32 volts, and if it's like longer than 50 centimeters, which is also issues sometimes. So always, for now, we can only make a sensor which is maximum of 50 centimeters long. And then I will show you the sensor. You can take off the bottom part. And this is a Nylon pole sensor. Yep.